Ladies and gentlemen, welcome to Geometry's Most Elegant Theorem. This, my friends, is exactly why you signed up for geometry to take it this year. To finally get to section 4 of chapter 9. And I'm going to give you a little name association here to get you going and to set the stage. You're going to see, it's not really a game, but it says name association game. A word, a name, is going to pop up on the screen, and I want you to think immediately of what pops into your head about a class in school that you would associate with it. For example, Shakespeare, bam, immediately you think of probably English or theater or something to that regard. Next one, bam, Mozart. You would think of music right away, just like I did. Next one, Sir Isaac Newton. You would think of the sciences, physics in particular for sure, but many of the other sciences. How about this one? Picasso, that's right, you think of art. How about this one? Neil Armstrong. No, by the way, not physical education. Neil Armstrong is not the guy that rode in the Tour de France. That's Lance Armstrong. Nice try. Neil Armstrong was the guy on the moon. Okay, so you think sciences. And of course, how about this one? Mr. Motter. Aha! You would think genius immediately. I understand. I would do the same thing. However, you think math. And of course, the one and only that we're talking about in this lesson, Mr. Pythagoras. You would think immediately Jurassic Park dinosaur. No, not that. You'd think math. Exactly. Now, a little comic relief for you. Check this out. Yep, you're going to see this old man standing right here. He's pointing at a triangle on the ground. He looks at his friend named George. Don't know his name. We'll call him George. George says, "You may be right, Pythagoras, but everybody's going to laugh if you call it a hypotenuse." And little Jack standing over here going, hee 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 hee, hoo 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 hoo, hee hee hee, that's funny, George, hoo hoo hoo, yeah, ha, ha, ha. Something like that. And then Pythagoras says, "You wait, old men, you just wait and see how big this theorem's going to be." And you got it. We were talking about the Pythagorean theorem. Now we're going to go way back to ancient Greece because good old Mr. Pythagoras himself, I sculpted that over the weekend for you guys. It took me a little bit. Sorry about the imperfection right there, but whatever. Just kidding, I didn't sculpt it. Little background on it. I'm not going to get into the history, but this is when he roamed the earth, 6th century BC. It was about 150 years prior to Mr. Plato, and no, not the Play-Doh stuff that my little 2-year-old plays with. This is Mr. Plato, like the famous guy. Yeah, that dude. Yep, and you guessed it, we are talking about geometry's most elegant theorem, the Pythagorean theorem. I can tell you guys this from the bottom of my heart. Anybody that's ever had any type of a math class, whether they're in school, whether they are, through high school, I should say, geometry, grandparents, parents, doesn't matter. If you say math to them, they'll probably say, "Oh, the only thing I remember is that a squared, b squared, c squared thing," and they'll get close to it. That is about the only thing 99% of the time that people remember from math. It's so crazy. So I guess Pythagoras, back to the, that comic example, I mean, I guess he was right. I mean, he probably was saying, "George, Jack, I can't do anything in terms of being I can't sing, I can't dance, I'm not going to star in American Idol, I'm not going to star in a Broadway show or anything. So you know what? I'm going to come up with my own theorem and make it pretty famous that everybody in the entire world for the rest of our lives are going to use." No wonder they laughed at him, but here we are. Crazy. Now, I am not going to teach you this. You all know it. I said it already, but I'm going to play 2 different videos for you guys. Not for me. They're actually music videos, which are pretty cool. And I think it's awesome because you should take some notes on it because there's a couple things in there, a couple examples that are going to help you to understand how to use this thing. So here we go. Here is video number 1. Enjoy the videos.
It's mathematical symbols and signs. The most complex become simple with time. Mathematics, see what you find when you start to look for it with a disciplined mind. Mathematics, logic and proof that is used to determine mathematical truth. It's mathematics. Step into class, and by the time the bell rings, I hope you're ready for math. In the right triangle, given 2 sides, use the Pythagorean theorem you can find. Unknown value, so you have 3. Label all the sides with an A, B, and C. Yo, looking for the C? This is where you find me. I am that side right across from the 90 degrees. The angle with the little square, shaped like an L for the legs that are there. If we call the legs, what we call the third side. It's the hypotenuse. Say it if you heard it right. Hypotenuse, longer than the other two. So to find the missing side, here is what you're gonna do. Set up this equation. C is on its own. Of the three numbers, it is always alone. It goes a squared, yeah, plus b squared, yeah, equals c squared, yeah. That's right. Use the Pythagorean theorem, you can find unknown values, so you have three. Label all the sides with an A, B, and C. In a right triangle given two sides, use the Pythagorean theorem, you can find unknown values, so you have three. Label all the sides with an A, B, and C. A squared, yeah, plus B squared, yeah, equals C squared, yeah. That's right, yeah. Use this equation when you find the other side. Yo, here's a way to do it when you're giving both legs. Square them, add them, see what you get. Take the square root of that, that's the last step. Now you just found the hypotenuse, right? It's a little different when one leg is missing. Set up the equation, everything in its position. Square the hypotenuse, same for the leg. Subtract the smaller number from the bigger one to get down to this last step. Take the square root. So I'm pretty sure that you know what to do, right? It's the last step. Take that square root. Now I'm pretty sure that you know what to do, right? In the right triangle given two sides, use the Pythagorean theorem, you can find unknown values, so you have three. Label all the sides with an A, B, and C. In the right triangle given two sides, use the Pythagorean theorem, you can find unknown values, so you have three. Label all the sides with an A, B, and C.
There you go. Video number 1. Here comes video number 2. I'll stop this one halfway through. It won't be as long, but it's a catchy little tune too. Check it out.
Look at a right triangle with a 90-degree right angle. Across from the right angles, the hypotenuse. It's no surprise the hypotenuse is the longest side. Now how do you find the hypotenuse's length if you know the length of the two other sides? Let's take you back to old ancient Greece. Pythagoras is gonna show you why. A squared plus B squared equals C squared. You see is the length of the hypotenuse. A squared plus B squared equals C squared, when A and B are the length of the other sides.
So there you go. Some fun little videos. I thought they were catchy. You can go check them out on YouTube. Probably sure to look them up. But anyways, here is the wording of the Pythagorean theorem. The official wording that needs to go into your notes if you haven't got it already. But this is actually number theorem 69. The number means nothing, as you know, but it's what's in the book. So it says the square of the measure of the hypotenuse of a right triangle is equal to the sum of the squares of the measures of the legs. And this is your formula: a squared plus b squared equals c squared. And remember, as you heard both videos pretty much say, important thing is by far this. This thing right here, the c, is always by itself, and it's always the hypotenuse. Sometimes the hypotenuse isn't over here to the right. It might be downstairs, it might be to the left, it might be up here in the left corner. Doesn't matter. The thing that's always by itself in the Pythagorean theorem is the hypotenuse length. And then, of course, these guys are just the leg lengths. That's it. So there is your theorem, ladies and gentlemen. And I'm going to tell you, I got another little catchy tune that I'm going to play in class for you. And I'm going to post another video that's pretty cool. It's an origami proof. A girl just folding some piece of paper and showing you how in the world the Pythagorean theorem comes about. It's pretty cool. Anyways, we're going to see you in class. We're going to have fun doing this. Pythagorean theorem, geometry's most elegant theorem. Congratulations. Later.